Oh, hello, grade 12. In today's lesson, we're going to be doing counting principles, and then we have grade 12 probability session. Let's see what we have got. So for the first time in my sessions, we'll be doing multiple questions. So I have this question 11, followed by another question 11, followed by two other question 12s, right? So all in all, we'll be doing 4 questions for the session today, right? Then let's start. It says a company uses what? Uses a coding system to identify its client. Each code is made up of 2 letters and a sequence of digits. For example, AD108 or RR45789. So from that, you can see that your 2 letters must come after each other, right? So it's a letter after the other, right? The letters are chosen from A, D, R, S, and U. So we are not choosing from a sample space of 26. Only 5 letters are chosen. Only 5 letters are our sample space, right? So we have to only choose from those 5 letters. Then letters may be repeated in the code. The digits 0 to 9 are used. So how many digits do we have if we are using 0 to 9? It's 10 digits, right? Don't be confused. 10 digits. But no digits may be repeated in the code, right? So the letters, yes, they may be repeated, but then not with the digits. The digits may not be repeated. Then 11.1 says how many different lines can be identified with a coding system that is made up of 2 letters and 2 digits. So here we must form a code that has what? 4 characters, which is 2 letters and 2 digits. Now, what are we going to do? So we are supposed to form a code with 4 characters, right? But then we know for the first two, those are for our letters. Then we have an option of choosing from how many letters. What is our sample space for the letters? It's 5. So in the first block, we are saying we have an option of choosing 1 letter from the 5 of the letters. So you have 5 as your sample space here. So you can choose 5. You have an option of choosing 5. Then on the second one, because now the events are independent, meaning it does not change the sample space, the first event does not affect the second event. So now if we have chosen a number, a letter here, it doesn't affect our event of choosing another letter on the second block. So that is to say, if I've chosen R here, it doesn't mean I should not choose R on the second one. So you can even see on their example here that they were able to repeat the letters. So you can choose R on the first event and also choose R on the second event. That means the sample space still remains the same. It's what? 5. But then with the digits, we were told you should not repeat the digits. So how many digits do we have? We have 10. So on the third block here, you have an option of choosing from the whole of those 10 digits. So you can choose 1 digit from those 10, right? But then here, the events are what are independent. So if you choose a digit here, you are not allowed to choose it again on the fourth one, right? So that affects our sample space. Now our sample space becomes what? 9. That is to say we have an option of choosing from 9 different digits on the fourth block, right? So here, suppose maybe we had chosen 2 as our digit. That means 2 here on the fourth block can no longer be part of the sample space. Now, if 2 is no longer part of the sample space, now we have an option of only choosing from 9 digits, right? So that is your solution. 5 times 5 times 10 times 9. What do we have? So all in all, that is gonna give us 2,250, and that's how you could have solved that one. Then 11. Now we have 11.2 says determine the least number of digits that is required for a company to uniquely identify 700,000 clients using the coding system, right? So in this case, you can see determine the least number of digits. That means we are no longer restricted to those 2 digits. We can have as many digits as we possibly can, right? Then here, what are they saying? The digits, we know they cannot be repeated. So we're just gonna go with the trial and error method. So if we already know, if we have 2 digits here, we're gonna have how many ways, how many codes? Only 2250. Now let's try if we have 3 digits. So we're still gonna have 5 times 5 multiplied by 10, a digit, another digit, and a third digit. So what is it gonna give us? So if you punch that in your calculator, you will just receive 18,000, right? Now, how many clients must we cater for? 700,000. So it's not enough. Now we must add another digit. 5 times 5 times 10 times 9 times 8 times 7. Alternatively, you can just multiply 18,000 by 7, because that's what we are doing here when we are adding a digit, right? Then if you multiply by 7, you're going to have 126,000. 126,000. Is it enough? No, we must cater for 700,000. So it's still not enough. Now let's add another digit. So we are adding a 5th digit. So multiply by 10, by 9, times 8, times 7, times 6. Alternatively, you could have just multiplied 126,000 by 6, right? Then that, punch that in your calculator, it's gonna give you 756,000, right? So how many clients must we cater for? 700,000. So you can see with the 5 digits, we have more than enough, right? So that means how many digits can we choose? It's 5 digits, right? 5 digits. Nice one. That's how you could have solved that one. Now we are done with that. Let's get to this one. The second question 11, it says, given the digits 3, 4, 5, 6, 7, 8, and 9, calculate how many unique 5 digits code can be formed using the digits above if the digits may be repeated. Now, how many? Let's count the digits first. How many digits do we have? 1, 2, 3, 4, 5, 6, 7 digits, right? So we have 7 digits and we are required to form a 5-digit code. Then 11.1.1 says the digits may be repeated, meaning here the event is what? The events are independent, right, of each other. So whatever you choose on the first block doesn't affect the second block. What you choose on the second block doesn't affect the third block, right? So we have an option of choosing from 7 digits, we must form a 5-digit code, right? So from 3 up to 9, we have an option of choosing from 7 digits. But then since when we choose that digit, it doesn't mean we don't have to put that digit on the second one. How many options do we have to choose from? Also 7 again. And then also again, it's independent events, right? So it does not change our sample space, right? It doesn't affect the upcoming event. So what do we have? 7 to the power of 5, which is going to give us 16,807, right? So we can form 16,807 codes if we are allowed to repeat the digits. Then here we are told the digits may not be repeated. So for 11.1.2, the digits may not be repeated. That means here now the events are what? Are dependent, right? So your first event will affect the outcomes of the second event, right? So now we have 11.1.2. Again, we must also form those 5 digits code, right? So on this one, on the first block, we have an option of choosing from the maximum sample space, 7. But then here, once we've chosen a digit, we cannot repeat it on the second block. So what does it do? It affects our sample space. So provided we had chosen 2 here, that means we cannot have 2 here on this second block. That means our sample space is no longer 7 but 6. Now we have an option of only choosing from 6 digit, right? On this one, if since this are what are dependent events, that means it will affect the other one. Now we're going to have a sample space of 5, then affect the other event, sample space of 4, affect the other event, sample space of 2, or of 3, right? 3, I mean. So that's it. And then having to write it as your solution, 7 times 6 times 5 times 4 times 3, right? So remember, this is not to say we are putting 7 digits here. We are saying we have an option of choosing from 7 digits, but then on each block, we're going to put just 1 digit, right? So this is probability. Then 2,520, right? That's it. So if we are not allowed to repeat the digits, we can only form 2,520 digits, right? Nice. Then 11.2 says how many unique 3 digits code can be formed using the above digits if the digits may be repeated, right? So here, number 1, the digits may be repeated. Note that one. Number 2, that means if the digits may be repeated, this now becomes what? Independent events, right? So your first event doesn't affect the outcomes of the second event. The code is greater than 400 but less than 600. The code is divisible by 5. Now let's check with this 2 last statements. What do they mean? So we have the numbers 3, 4, 5, 6, 7, 8, and 9. Now we are being told that the digit must be, so the code, let's just say the code must be greater than 400 but less than 600. So C for code. How many digit code must be formed? Only 3. Now if my code is to be greater than 400 but less than 600, that tells you for the first digit here, I'll have to choose a number that is either a 4 or a 5, right? So I will have to choose from these 2. Then how many different ways can I choose? Then we only have 2 options here, right? So we have an option of putting either a 4 or a 5. So our sample space is only 2, right? For this one, it's restricted, right? We can only choose a 4 or a 5. So that's the 2 there. And then remember the digits may be repeated. So if the digits may be repeated, what's the sample space here for the second event? For the second event, we have the option of choosing from the maximum sample space, which is 7. Remember, if I choose either a 4 on the first digit, it doesn't prohibit me from choosing a 4 again on the what? On the second digit, because they said the digit may be repeated. But then the third statement says this code must be divisible by 5, right? Now, knowing the rule of numbers, we know that in order for a number to be divisible by 5, it has to either end with a 0 or 5. But then here we do not have a 0. Our number starts from 3, right? So that means in this case, in order for our code to be divisible by 5, it has to end with a what? A 5. So what is the sample space for the last event or the last digit? It's only 1. We have the option of choosing only a 5, right? Then how many codes can be formed from that? So we're just going to multiply all these numbers here. 2 times 7 times 1. It's going to give you what? 14 codes, right? So we only gonna have 14 codes if they say the code must be greater than 400 but less than 600, and then also must be divisible by 5, where the digits may be repeated. Nice. Then let's get to question 12. So let me just erase here. So question 12 says the digits 1 to 7 are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated, right? So we are required to form a 4-digit code, and then the digits are 1 to 7, meaning we have a sample space of 7, right? So from 1 to 7, those are only just 7 digits, and then are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated, and the code must be an even number bigger than 5,000? So you get that. So you must highlight your very important statement, right? So now we must create a 4-digit code. So I can just draw 4 blocks. So I know I must create a 4-digit code. But then the code has conditions. It must be greater than what? 5,000. So we can say code greater than 5,000. Code must be an even number, right? The code must be an even number. So let's check here. The numbers that we are given here are what? 1 to 7. So 1 to 7, we have 1, 2, 3, 4, 5, 6, 7, right? So let me just erase here. We know code must be greater than 5,000. Now we know if the code must be greater than 5,000, that means the numbers that can go in there are what? Are either 5, 6, 7 on the what? On the first block, right? But then if it has to be divisible by 2, if it has to be even, that means it must be divisible by a 2, right? Then by even, it means also the last digit must be even numbers. So a number is even if it has its last digit being an even number. So how many even numbers do we have here? 2, 4, 6, right? So I circled the even numbers. Then on the last one, remember this 2, 4, 6 can either go on the last block because they are the ones that are going to determine whether this thing will be what? Will be even, right? This code will be even. Now, if you can check, 6 appears in 2 events. It can either go on the first block or it can go on the last block. But then remember, the condition is we do not have to repeat the digits, right? So now we have to come up with cases because we see our 6 will give us a problem. Since when we put it on the first block, we cannot have it on the sample space of the last block. So now we're going to have a case. We'll just name it case number 1. So let's say case number 1. Case number 1 is whereby we choose 6 as first digit. Ne? So if we choose 6 as the first digit, how many? The code must have what? 4 letters. Our numbers are 1, 2, 3, 4, 5, 6, and 7. Now we said our even numbers are 2, 4, and 6. Now we are putting 6 here on the first digit. So the sample space or the probability of just picking 6 from that is just 1, right? So you can only just pick 1 6 there. There's 1 6. Then on the other one, on the last digit now, we must have even numbers, right? Which are 2, 4, or 6. Now, since you have picked out 6 and then you cannot repeat the digit, that means your sample space changes now. So this first event will affect the what? The outcomes of the second of the last event, right? Then which is what? 2. Now you have the option of either choosing from a 2 or a 4. 6 is no longer part of that. It's not part of the sample space because it's already in the what? In the first block. Now having chosen a digit here and also a digit here, you had a sample space of 7, but then now you have a digit here and you have a digit there, right? Then the sample space becomes what? 5. That means you are only left with the option of choosing from how many numbers? 5. Remember, you cannot repeat the digit. So 5. If you choose a digit here, now it affects your sample space. Remember, the events here are dependent. Now you will have an option of choosing from 4, right? So that is for the case whereby our 6 is the first digit. Now let's check the case whereby now let's check case number 2, whereby either a 5 or a 7 is the first digit. So we have 1, 2, 3, 4, 5, 6, 7. And now we are saying either a 5 or a 7. So let me put it in blocks. Either a 5 or a 7 will go as the first digit. So we must form a 4-digit code. So here we are saying either 5 or 7. So what is the sample space for that? You have 2. There are 2 options, right? You can either choose a 5 or a 7. So there are 2 ways in which you can choose from that, right? Either you put a 7 there or you put a 5. Then let's check. In this case, this is the first digit and this is the last digit. Now, your first digit, it doesn't affect the probability of the last event. So the last event becomes what? 2, 4, 6. You have the option of choosing from 3 numbers, right? Which are your even numbers. That's 2, 4, and 6. That's if you choose 5 or 7 as what? As the first digit. Now, having chosen a digit here and a digit here, now you have used 2 digits from the sample space and you cannot repeat those digits. Now it leaves you with a sample space of how much? 5. So here you have an option of choosing from 5 digits, and here you have an option of choosing from only 4 digits, right? Then now, to get the whole probability, we can just say, okay, let's get the solution for this one. 1 multiplied by 5 multiplied by 4 times 2. It's gonna give us what? 40. So from here, the codes with 6 as the first digit are only just gonna be 40. And the codes with either a 5 or a 7 as the first digit will be 2 times 5 times 4 times 30, 120, right? Now the total is gonna be what? The total is just gonna be the addition of the 2. So we have 40 plus 120, it's gonna give us 160. So we can form 160 codes if the option is the code must be greater than 5,000 and the digits may not be repeated, and also again it must be what? Even. So that's how you could have answered that one. Now let's check the last one. It says question 12, consider the word maths, right? 12.1 says how many different 5 letters different. You can see with this one, it says different 5 letters arrangement. So in other words, by saying different 5 letters arrangement, it's telling you that you should not repeat what? The letters, right? Then can be made using all the above letters. How many 5 different 5 letter arrangements can be made using all the above letters? So if it doesn't put the word different, so if it just gives you words like this and it says how many 5 letter arrangements can be made using all the above letters, then we could have assumed that we are supposed to repeat the letters. But then once it puts the word how many different, so the keyword is different, that means we cannot repeat your letters, right? So here, since we cannot repeat your letters, we're going to have, so maths is what? A 5 letter word. And then we are supposed to form 5 digits, 1, 2, and then 5, like that. So on the first block, we have an option of choosing from 5 letters. But then once we've chosen a letter, it cannot be part of the sample space of the second event. So that decreases our sample space to 4. And then again, when we've chosen a letter from that sample space of 4, then now we have a sample space of 3, followed by a sample space of 2, and just only 1 letter that is left. So that can be written as what? 5 factorial, right? Because 5 factorial is 5 times 4 times 3 times 2 times 1, right? And then what are you going to have? For that one, you're going to have 120. So if you punch it in your calculator, say 5 factorial, it's going to give you 120. Now 12.2 says determine the probability. Careful. Determine the probability, right? So we know with the probability of an event is the number of chances that the event may occur over the total number of the sample space, right? So this is what you should think of when you are required to calculate the probability. So determine the probability that the letters S and T will always be the first 2 letters of the arrangements in question 12.1, right? And then here you are given that, of course, you cannot repeat the letters, right? So now let's check. They're saying S and T will always be the first letters, right? So that means they will follow each other. So let me have a case whereby S and T must always be the first. So I can either have an option where S comes first and T follows, right? Then since S and T are now out of the sample space, then we are only left with 3 letters for here, only left with 2 letters if we put 1, only left with 1 letter here. But then that's not the only way we can have that. We can also have S and T coming as the first the first characters in the form of T and S. Remember, they did not tell you that it must be specifically ST. So they just said S and T must follow each other and must be the first, right? So you can either have ST and TS. So that means you have 2 factorial ways of putting that. Then here, T and S are no longer part of the sample space. Now you are left with 3 letters, here 2 letters and 1, right? So this one, you can just say you have 2 factorial ways to do it. So 2 factorial ways means you have 2 different ways to put it. You can either have an ST or you can have TS. So for that one, we're just going to go so we're just going to go to, let me write it here, erase here. So for this one, we're going to have, since S and T can be put in 2 factorial ways, right? 2 different ways. When I have 2 factorial multiplied by what? 3 times 2 times 1 is the same as having what? 3 factorial, right? So we can have 2 factorial times 3 factorial. It's going to give us 12, right? But then since this is probability, our probability has to be probability of E over NE over the sample space. So we are saying the number, the number, the number of chances in which the event can occur is 12 over what? A sample space of 120. So we can have 120 codes being formed there, or arrangements formed out of what? And then here, if we are told S and T must always come as the first letters, then we can only have 12 options of doing that, right? Then 12 divided by 120, it's gonna give us 0.1, and that becomes your probability, right? Or alternatively, you could have just said S and T, they're gonna be taken as 1 and 1, right? So 1 times 1 times 3 times 2 times 1, you could have got this one as 6. And then again here, 1 times 1, it's 1 times 1 times 3 times 2 times 1, it's still 6. Then if you say 6 plus 6, it's going to be 12 still, right? Then there you go. You could have got 12 over 120, then is equals to 0.1. And that's your probability. Nice one. That's where our session ends, guys. Please watch this video as many times as you can, and good luck with your prelim exams. Ra.